Unit 3 review. This is a we do, I do review. I'm going to go ahead and go through the we do side, and then you're going to work on the I do side on your own. Okay, so let's look at number 1. Number 1 says find the rate of change. So we have a table, but I need you to remember that a rate of change is the same as slope. So rate of change equals slope. Those are the same thing. So in order to find the slope of a table, remember we use the formula y2 minus y1 over x2 minus x1. Okay, and I'm going to pick any point. So I'm just going to go with the second one and the third one. So this is going to be x1, x2, y1, y2. And remember in a table that the first column is always x and the second column is always y. Okay, so I have 184 minus 196, and then I have 1 minus 0.5. Okay, so 184 minus 196 is negative 12, and then 1 minus 0.5 is 0.5. And negative 12 divided by 0.5 to see if we can simplify is going to be negative 24. So negative 24. Okay, now let's look at the units. So the units for x is going to be time. And the units for y is going to be height, which is in feet. So what this is saying, since it's negative, is that it is losing height in 24 seconds. So every 24 seconds, it is losing 1 foot. Remember, this could be over 1. So this is every 24 seconds. The height decreases by 1 foot. Okay. Great. Now let's look at number 2, which is again a rate of change problem, except now we have a graph. So remember that rate of change is the same as slope. And to find the slope on a graph, we use rise over run. So I'm going to go ahead and use these 2 points right here. So if I go up 1, if I pay attention to what the units are on the y-axis, you'll see that it's going up by 80. So this is actually going up 80. So rise 80. Okay, and then if I go right 1, notice I land at my other point. But instead of going right 1, if we look at the units on the x-axis, it's going by 2s. So this is going to be 2. Okay, so 80 divided by 2 is 40, which we can write as 40 over 1. And remember that our y-axis here was distance in miles, and our x-axis was time in hours. So this means that it goes 40 miles in 1 hour. So it goes 40 miles per 1 hour. Okay. So remember, same thing. We're talking about slope, but we just have to add those units in there. Okay, let's look at number 3. Number 3 says find the 0, y-intercept, slope, and linear equation. So we are finding 4 things here. So let's pay attention to the 0 first. Remember, 0 is another word for x-intercept. So x-intercept. And remember, the x-intercept is where it crosses the x-axis. Okay, so it crosses the x-axis right here. And then we notice that that's going to be 1, 2, 3, 4, 5, 6. So our 0 is equal to 6, 0. Okay. Now let's find our y-intercept. Remember, our y-intercept is where it crosses the y-axis. So right here. So our y-intercept is going to be 1, 2, 3, 4, -4. So 0, -4. Okay. Now let's look at slope. Remember, slope is rise over run. So slope equals rise over run. We're going to use those 2 points to find our slope. So I'm going to go up 1, 2, 3, 4. Okay, I rose 4. And I'm going to go to the right 1, 2, 3, 4, 5, 6. Okay, so this is our slope, 4 over 6, but now we have to check if it reduces. So 4 and 6 can both be divided by 2, so this can turn into 2 over 3. So this is going to be our slope. We just reduced 4 over 6. Okay, last thing we're going to look at is our linear equation. Remember, our linear equation is y equals mx plus b. We know that m is the slope and b is the y-intercept. And we already found those two things in our problem. So we're going to write y equals slope, which is 2 over 3x, plus our y-intercept, which is a -4. So I'm just going to write -4 instead of plus -4. Okay, and that's our answer. Okay, let's look at number 4. Number 4 says find the domain and range. So remember that this type of function is a continuous function. So continuous. Remember, a continuous function is connected by a line. So we're going to look at both ends of this point. So I'm going to show you 2 different ways. So one way is that we can look at each of these points and you can label them for me. Okay, so this point right here is -5, okay, -2. And this point over here is 4, 3. So we know that this side right here has an open dot, and we know that open dots are less than. And this side over here is a closed dot, which is less than or equal to. So we can write the domain as -5 less than x less than or equal to 4. Remember, the smaller number always comes first. And then range the y values as -2 less than y less than or equal to 3. And that is one way to find the domain and range. Okay. Another way to find the domain and range, I'm going to go ahead and erase this. You're going to notice that we're going to get the same exact answers. And I'm showing you guys this because some of your teachers probably showed you how to do this differently. So this is one way. Okay. Another way is by putting in those boundaries. So I'm going to say that domain is red. So remember, domain is our x's. Okay? So I need to see where the smallest x value is on our graph, which would be over here by -5. That's the smallest one. Okay, then we have to find the biggest one, and the biggest one is right here at 4. Same thing, we're using the same symbols of closed dot and open dot. So we're going to write this as -5 less than x less than or equal to 4. Okay, let's do the same thing with range. Let's make range blue. Okay, so for range, I'm looking at the smallest part on the y's that this graph goes to. The smallest part is going to be right here. It's going to go through that -2. And then the tallest part that this graph goes through is 3. See right here. So what we did is we put our function in a box, which means that if any part of our function is outside of that box, then you drew this box wrong, because our function needs to be restricted inside of this box. Okay, so if I was writing the range of this, same thing, I'm looking at the smallest number, which is -2 less than y less than or equal to 3. Okay. Now let's look at number 5. Number 5 says, what is the reasonable domain and range? Okay, so this is a word problem. Let's go ahead and read this problem. Okay, it says Joe had a summer job that paid $7 an hour where he worked between 15 and 35 hours every week. So we need to figure out what is the independent variable and what is the dependent variable. So the independent variable and the dependent variable. Okay. Remember, the dependent variable depends on the independent variable. So would the amount that Joe gets paid depend on the hour he works? Or would the hours he work depend on how much he gets paid? Okay. So the money he makes, so the money Joe makes per hour depends on how many hours he works. So that means the independent variable is hours Joe worked. So remember that independent is our x and dependent is our y. Okay? So now we can use this to find our reasonable domain and range. So since domain is x's, we know that Joe can work between 15 and 35 hours. So that means he can work 15 hours or he can work 35 hours. Right? He can work any hours in between. Okay? And then for the range, let's say Joe works 15 hours. If he works 15 hours and he gets paid $7 an hour, 15 times 7 is 105. So he would make 105 less than or equal to y less than or equal to 35 times 7, because that's how much he would make if he worked all 35 hours, $245. This is a continuous function. Okay. Number 6 says write the linear equation. Billy is charged $50 to rent a car for the week. He also has to pay 25 cents per mile. So he's charged $50. So that means no matter what, he has to pay $50, even if he drives 0 miles or if he drives 1,000 miles. And then every mile he drives, he has to pay a quarter. So remember the word per tells us that the word after it is our x. So we would write this as y equals 0.25x plus 50. Because that x can change. That x is how many miles he's driving. But that 50 will never change. That's our answer. Okay, number 7. Number 7 says write the linear equation. So if we look at this table, we know right away that we do not have a y-intercept. Since we don't have a y-intercept, we're going to have to find that y-intercept. Okay, but first, I'm going to show you guys that we need to find the slope. So remember, linear equation is y equals mx plus b, where m is the slope and b is the y-intercept. So remember, to find slope, that's y2 minus y1 over x2 minus x1. We can choose any point, so I'm just going to choose the top two. And I'm going to label it x1, x2, y1, y2. So I have 9 minus 10 over 4 minus 3. 9 minus 10 is negative 1. 4 minus 3 is 1. Negative 1 divided by 1 is negative 1, so that's our slope. That's our m. And then we have to use the function y equals mx plus b to find our b value. So I'm going to choose another point to be my x and my y. So let's choose this point right here. This is going to be my x and this is going to be my y. So instead of y, I'm going to write 8 equals m, which is negative 1, and then x, which is 5, plus b. So our goal here is to get b by itself. So you could either get b by itself by solving for b, like a multi-step equation, or you can use nsolve on your calculator. Okay. Either way, when you use either step, you're going to get b is equal to, let's see, 13. Okay. So now that we have m and b, we can go ahead and write our answer. So y is equal to negative 1x plus 13. Okay, let's look at number 8. Number 8 says use the point-slope formula to find the equation. So it gives us a point and it gives us a slope. So we're going to write the point-slope formula, which is y equals, y minus y1 equals mx minus x1. I'm going to go ahead and label what these points are. So that 4 is going to be x1, the negative 6 is going to be y1, and the 1/2 is going to be m. So this becomes y minus negative 6 equals 1/2 x minus 4. Okay. Let's see. I'm going to go ahead and change this minus a negative into plus a positive. So I have y plus 6 equals. Then I'm going to distribute this 1/2 inside. And remember, distribute means to multiply. So 1/2 x minus 2. Then I'm going to subtract 6 to get y by itself. Then I'm going to get y equals 1/2 x minus 8. And remember, what form is this? This form right here. This is slope intercept. Okay, and let's go one step further and turn it into standard. Remember, in standard, we have to get x and y on the same side. So I have y equals 1/2 x minus 8. I'm going to have to subtract 1/2 x to the other side in order to get x and y on the same side. So I have negative 1/2 x plus y equals negative 8. I cannot have a negative 1/2 in front of the x. So I'm going to have to multiply by the denominator and a negative number. So I'm going to multiply by negative 2 every single one. Okay? So this is going to become x minus 2y equals 16. This is my answer in standard form. Okay, let's look at number 9. Number 9 says change point-slope form into slope-intercept form into standard form. So I give you this first form. Our first step is to turn it into slope-intercept form. Okay, so that means I'm going to distribute that 3. So I get y minus 5 equals 3x plus 6. I'm going to add 5 to both sides. Y equals 3x plus 11. This right here is slope-intercept form. And then remember, to turn it into standard form, I have to get x and y by itself. So I have y equals 3x plus 11. I'm going to subtract 3x from both sides. So I get negative 3x plus y equals 11. I can't have that negative right there, so I'm going to multiply every single one by a negative 1 to get rid of it. So then I have 3x minus y equals negative 11. That's my answer for standard form. Okay, and last one, number 10. Number 10 says using function notation, solve for the following. So remember, if we have a number inside the parentheses, this is x, meaning we're going to take this number and plug it in for x. So I have 5 times 2 plus 9. So instead of x, I put a 2. 5 times 2 is 10. 10 plus 9 is 19. That's my answer. And I can write that answer as 2, 19. Okay. Same thing here. It says find x when f of x is 19, so this is my y value. Remember, f of x means y. So this is like saying 19 equals 5x plus 9. We need to get x by itself. You can get x by itself using insolve, menu 3-1, or just solving to get x by itself by hand. Either way, you're going to get x is equal to 2. So we get the point 2, 19. Okay. Lastly, it says find the range, which is y, if domain is 0, 3, and 6. So domain is x. Meaning this problem is going to look a lot like this problem right here, where we had to plug in 2 in for x. Okay. So I'm going to first plug in 0. So I have 5 times 0 plus 9. Then I have 5 times 3 plus 9. 5 times 6 plus 9. Notice that I plugged in each of these numbers here. This is where those numbers came from. Okay, 5 times 0 is 0. 0 plus 9 is 9. So this is the point 0, 9. 5 times 3 is 15. 15 plus 9 is 24. So this is the point 324. 5 times 6 is 30. 30 plus 9 is 39. This is the point 639. Notice that 0, 3, and 6 right here are all the domain numbers, which means that 9, 24, and 39 must be all the range numbers. So the range is going to be 0, 24, 39. Okay, and that's the end of the review. Go ahead and work on the I do side.